Hello there, and welcome to Mysteries of Earth. When you look up at the moon tonight, what do you see? A glowing orb, serene, distant, untouched, a celestial companion that has inspired myths, poems, and songs for millennia. But hidden beneath that silver glow is a truth far more human than cosmic. The moon is not just a rock orbiting our planet. It is a stage for politics, law, and ambition. A place where the dreams of humanity collide with rules we created to keep the universe from descending into chaos. It may seem strange to think about laws on a barren, airless sphere, 384,000 kilometers away. After all, only 12 humans have ever walked its dusty surface, and even fewer have looked out across its craters with the weight of history on their shoulders. Yet, as soon as humans realized we could reach space, we realized something else. The moon could become the next battlefield if we weren't careful. The year was 1967. Earth was divided. The Cold War pitted superpowers against one another, each racing to prove technological supremacy. The United States and the Soviet Union were locked in a silent, invisible duel that extended from the skies to the edge of the cosmos. And yet, amid this tension, something remarkable happened. These rivals, along with the United Kingdom, agreed that the moon would not be a stage for human conflict. They put pen to paper and created what would become the foundation of space law, the Outer Space Treaty. Its full name is formidable, almost ceremonial. The Treaty on Principles governing the activities of states in the exploration and use of outer space, including the moon and other celestial bodies. A mouthful, yes, but behind the formal phrasing lies a bold, unprecedented promise. The heavens, for all their vastness, should belong to no one nation, no one flag, no one ideology. The Outer Space Treaty made it clear that the moon, and all celestial bodies, must be used exclusively for peaceful purposes. Weapons of mass destruction were strictly prohibited, military occupation forbidden. Every activity had to be transparent, cooperative, and guided by a spirit of collective stewardship. Imagine that. A law that says you can visit a world, explore its mysteries, even use its resources, but you cannot claim it as your own. Planting a flag, a gesture so deeply ingrained in human history, does not equal ownership. You can leave footprints in the dust, but no signature in law marks it as yours. The moon became, in essence, a neutral territory, a cosmic commons where humanity's ambition was checked by principle. Yet, as with any rule, the devil lies in the details. The Outer Space Treaty left room for interpretation, gray areas that were invisible to the negotiators of 1967. Resource extraction was not fully regulated. Commercial activity wasn't fully anticipated. Who exactly has the right to mine the ice in a shadowed crater? Could a private company build infrastructure on lunar soil and operate as if it owned that land? The treaty had ideals, but ideals rarely cover the messy realities of progress. In 1979, the Moon Agreement attempted to address some of those gaps. Its vision was even more audacious. The moon's resources were to be considered the common heritage of mankind. Any minerals, ice, or other riches should be shared, with benefits flowing even to nations without space programs. In theory, this was a plan for cosmic fairness, a recognition that humanity's reach should not create new inequalities. In practice, it failed. Major spacefaring nations, the United States, Russia, China, refused to sign. The Moon Agreement remained the realm of minor space powers, symbolic rather than practical. Why? Because space had begun to change. By the late 20th century, it wasn't just governments reaching for the stars. It was corporations. Companies with rockets, ambitions, and balance sheets entered the lunar conversation. Mining ice for fuel, extracting rare minerals, building infrastructure. The notion of a shared inheritance suddenly clashed with profit motives and national strategies. Today, the Outer Space Treaty still governs the Moon, but it is a framework written in a different age. A world without smartphones, without multinational space corporations, without billionaires planning their own lunar bases. It enshrines peace, but leaves questions unanswered. How far can a private entity go in using resources? What constitutes peaceful purposes when we're building solar farms or fuel depots on a foreign celestial body? Who arbitrates disputes between nations or companies if two claim the same crater? This legal landscape is further complicated by voluntary agreements, like the Artemis Accords, introduced by the United States in 2020. These non-binding principles attempt to modernize lunar law for the 21st century. Countries that sign commit to sharing scientific data, preserving Apollo-era heritage sites, and avoiding conflict over resources. More than 40 nations have agreed, creating a patchwork of voluntary compliance. But key players, including Russia and China, remain outside the framework. The result is a strange, delicate balance, a celestial world governed by treaties written decades ago, modern guidelines followed voluntarily, and mutual goodwill that may be tested as humanity steps onto the lunar stage once more. So what does this all mean for the next generation of explorers? The Moon is no longer just a target for symbolic glory. It is a geopolitical chessboard, a laboratory for science, and a testing ground for humanity's legal imagination. The treaties of the past promise peace, but the realities of the future promise complexity. Where one astronaut sees a crater, a scientist sees data, a miner sees resources, and a diplomat sees a potential dispute. All coexist in the same vacuum, all waiting to collide. And yet, there is a certain poetry in it. The same moon that inspired ancient myths, guided early calendars, and sparked endless wonder, is also a mirror of humanity's highest ideals and deepest conflicts. A place where law meets ambition, where principle meets profit, and where the quiet dust carries the weight of our species' first attempts at interplanetary governance. In that sense, the Moon is not just a satellite of Earth. It is a laboratory for human civilization itself. How we behave on its surface, how we negotiate its resources, how we preserve or exploit its treasures, may well shape not only the next decades of lunar exploration, but the future of humanity beyond our planet. Because the Moon is the first world where humans must think globally, act collectively, and tread carefully, or risk repeating earthly mistakes on a scale where consequences are permanent, and there is no rescue mission home. So, as you gaze at that pale, familiar circle tonight, consider this. The Moon may look peaceful, untouched, eternal. But beneath that placid exterior, humanity has already left its mark, not with footprints, but with laws, principles, and disputes. The stage is set, the players are ready, and the next act is only just beginning. And yet, law and politics are only one part of the story. Beneath its legal boundaries lies a far stranger reality, a world of lopsided gravi, hidden craters, and an asymmetry that tells a tale billions of years in the making. The Moon, it turns out, is not the smooth, perfect sphere we imagine from Earth. It has a secret life, a physical personality, and an internal structure that is just as mysterious as the human dramas playing out above it. In the next chapter, we will uncover the Moon's hidden lopsided nature exploring the forces that shaped its uneven surface, the mysteries buried beneath its crust, and the strange gravitational quirks that make our satellite both familiar and profoundly alien. The moon's hidden, lopsided nature. Look up at the moon tonight. That pale, glowing disk hanging silently above Earth. It seems perfect, doesn't it? A flawless sphere, smooth and symmetrical, a cosmic pearl floating in the black. But appearances are deceiving. The moon is anything but perfect. It is lopsided, unbalanced, and oddly shaped, a relic of violent cosmic events and ancient forces that still echo in its gravity today. The first clue comes from its mass. Scientists have measured the moon's gravitational field with astonishing precision. What they found is startling. The center of mass is offset about 2 kilometers toward Earth. 2 kilometers may sound trivial, but on a planetary scale, it's significant. This uneven distribution of mass means the near side, the face we always see, is heavier, denser, more gravitationally loaded than the far side. And this hidden imbalance is no coincidence. It has profound consequences. One of those consequences is the moon's steadfast gaze. Why do we always see the same side of the moon? Why does it never rotate to show us its far side? The answer lies in physics. Tidal forces between Earth and the moon gradually slowed the moon's rotation until it matched its orbital period. That's tidal locking, and it is stabilized by the moon's uneven mass. Like a spinning coin that always settles on its heavier edge, the moon presents the same face to Earth. But the far side, hidden from view, tells a very different story. Step across the lunar divide, and the contrasts are remarkable. The near side is dominated by smooth, dark plains, the Maria formed by ancient lava flows. Volcanoes once erupted here, spilling molten rock that cooled into vast black sheets. These lava plains also carry unusual concentrations of radioactive elements, like uranium, thorium, and potassium. It is a world shaped not only by impacts, but by fire from Wit, Hin, a side bathed in both earthlight and geological fury. The far side, by contrast, is rough, jagged, and mountainous. Its crust is thicker, its volcanic history less pronounced, its surface marked by countless craters and ridges that hint at billions of years of bombardment. Where the near side is calm and patterned, the far side is wild and untamed. It is as if the moon, once a single molten sphere, split into 2 personalities, one orderly, one chaotic. How did this asymmetry come to be? Scientists have proposed several intriguing theories, each stranger than the last. One of the most compelling ideas involves the early influence of Earth itself. When the moon formed, likely from a cataclysmic collision between the young Earth and a Mars-sized body, it was molten, a glowing sphere of magma. The side facing Earth would have been constantly exposed to our planet's heat. That extra warmth could have slowed the cooling of the near side, keeping its crust thinner, while the far side cooled faster and formed a thick, rigid shell. This uneven cooling, over millions of years, may have locked the moon into its lopsided shape. The near side remained malleable, allowing volcanic flows to fill basins and form the Maria we see today. The far side hardened and preserved its rugged topography, a frozen testament to the moon's violent infancy. It is a planet-sized diary, written in molten rock and radioactivity. But the Earth heat theory is not the only possibility. Some scientists speculate that the moon may have once had a companion, a smaller, twin moon that eventually collided with it. Imagine 2 young moons dancing around Earth, only to smash together in a cataclysmic embrace. The impact would have redistributed mass, leaving one side thickened, the other scarred. Such a collision could explain why the far side is so much thicker, and why the near side bears the volcanic evidence of flowing lava and lighter crust. The evidence for this twin moon scenario is subtle but intriguing. Lunar gravitational anomalies, measured by orbiters and probes, reveal concentrations of mascons, buried beneath the surface. These regions tug subtly on orbiting spacecraft, forcing careful adjustments to their trajectories. On Earth, gravity is mostly uniform, but on the Moon, these hidden lumps distort the invisible field that governs motion in orbit. They are like fingerprints of ancient chaos, frozen in stone. And the asymmetry is not just theoretical. NASA missions, including the Apollo program and subsequent orbiters, have mapped these mass concentrations in detail. The Moon's crust is about 20 kilometers thinner on the near side than the far side, giving scientists clues to its internal composition. Volcanic rocks and radioactive elements are unevenly distributed. Even if you could remove all craters and smooth out the surface, the Moon would still be slightly elongated, stretched in the direction of Earth. It is a subtle, almost imperceptible deformation, but a deformation that has persisted for billions of years, a cosmic scar of formation and evolution. This lopsided nature also affects future exploration. Spacecraft navigating lunar orbit must account for the gravitational quirks caused by mascons. Landing near these regions can be tricky, requiring precise calculations to avoid being subtly pulled off course. Even the paths of future rovers and landers must be plotted with this hidden imbalance in mind. The Moon, which appears so tranquil from Earth, is in reality a world with a complex personality, its gravity whispering secrets to those who study it. But there is another layer of mystery. The radioactive elements concentrated on the near side, thorium, uranium, potassium, hint at a deeper story of planetary differentiation. These elements were once molten and mobile, migrating through the crust during the Moon's fiery youth. Their uneven distribution is a window into the early dynamics of lunar formation, offering clues about the internal heat, volcanic activity, and chemical processes that shaped our satellite. In other words, the Moon is not just a rock. It is a laboratory of planetary science, holding clues not only to its own history, but to the history of Earth and the solar system itself. And yet, despite centuries of observation, the Moon retains its secrets. The far side remains largely unexplored. Only one mission has landed there, China's Chang'e 4 in 2019, revealing a world completely alien compared to the familiar near side. Rugged, cratered, mysterious. A place where Earth is always hidden, where sunlight arrives at different angles, where the lopsided mass of the Moon continues to govern every motion of orbiting satellites. It is a reminder that we have seen only one face of our companion, and much remains to be discovered. So the next time you look up at the night sky, that seemingly perfect Moon is hiding a complex story beneath its calm exterior. A tale of molten beginnings, hidden gravitational anomalies, twin moons that may have collided, and a side bathed in Earth's warmth that shaped its surface for billions of years. The Moon is a world of duality, asymmetry, and mystery. A cosmic puzzle that continues to challenge our understanding. And what does this mean for the future? As humans prepare to return, to build habitats, landers, and perhaps even colonies, this hidden lopsided nature becomes more than a curiosity. It affects where we land, how we explore, how we build, and even how we think about the moon as a stepping stone into the rest of the solar system. The moon's asymmetry is not just a scientific oddity. It is a practical challenge, a secret map written in rock and gravity that will guide our footsteps long before settlers set foot on its surface. But beneath the gravity, anomalies, and crustal asymmetries lies an even stranger question. Could this lopsided world, seemingly dead and desolate, actually harbor remnants of life? Microbes we brought, or perhaps dormant secrets waiting to be discovered? The moon's uneven crust, its shadowed craters, and its hidden lava tubes may not only tell the story of its formation, but also guard clues to a cosmic experiment that began the moment humanity first set foot on its surface. In the next chapter, we will explore that very possibility, the lingering traces of Earth on the moon, from microbes that may have hitched a ride on Apollo missions to the question of forward contamination. Did humanity, in reaching for the stars, accidentally seed life on another world? And if so, what might still survive in the silent, shadowed corners of our celestial neighbor? Microbes on the moon. Did we contaminate it? The moon. Silent. Lifeless. A barren landscape of craters and dust. Or is it? For decades, scientists have wondered whether humanity, in its audacious drive to explore, may have left more than footprints on our celestial neighbor. Could the first visitors to the moon have inadvertently carried with them the tiniest passengers, microbes hardy enough to survive where no human could? When the Apollo missions began in 1969, astronauts carried with them not only cameras, rock hammers, and the dreams of a generation, but also bacteria. These invisible companions clung to spacesuits, equipment, and the very soil they touched. At the time, mission planners were aware of forward contamination, the possibility of Earth life hitching a ride to another world. But the understanding of microbial survival in space was limited. The focus was on rock samples and the thrill of exploration. The potential for contamination was acknowledged, yet treated as a distant, almost theoretical concern. The story of Surveyor 3, a robotic probe that landed on the moon in 1967, offers a tantalizing glimpse into the mystery of lunar microbes. When astronauts of Apollo 12 visited the probe in 1969, they brought back parts of it for analysis. To their surprise, bacteria, specifically Streptococcus mitis, were reportedly found on components that had been sitting on the lunar surface for over 2 years. Could these tiny organisms really survive in the harsh, airless vacuum of the moon? Were they remnants of the probe's earthly past, clinging stubbornly against impossible odds, or mere contamination introduced during analysis back on Earth? The idea is both unsettling and mesmerizing. For bacteria to survive on the moon, they would have had to endure conditions that would annihilate almost any known life form: extreme radiation from the sun, dramatic temperature swings of hundreds of degrees, near total vacuum, and the abrasive, oxidizing lunar dust. Yet here on Earth, we know of extremophiles, organisms that thrive in the most hostile environments imaginable. Some can endure the cold vacuum of space for months. Others can remain dormant for years, waiting for the right conditions to awaken. Could the moon, then, harbor dormant microbes, frozen in the lunar regolith, waiting for the tiniest hint of moisture to stir back to life? Modern experiments on the International Space Station, ISS, shed light on this possibility. Microbes have been exposed to space, subjected to vacuum, radiation, and temperature extremes, and some survive. Tardigrades, the so-called water bears, can endure complete desiccation and radiation, that would obliterate most life. Certain bacteria form spores, allowing them to hibernate for decades, even centuries. The implication is profound. Life is more resilient than we ever imagined, and the moon may already be hosting species of Earth origin, invisible, imperceptible, yet enduring. But the story of microbial survival on the moon is not just about biology. It's a cautionary tale about human ambition. Forward contamination is more than a scientific curiosity. It is a moral and practical challenge. If humanity introduces life to another world, we risk altering environments before they can be studied in their pristine state. Every Apollo mission, every lunar lander, every probe carries this potential. A single drop of microbial contamination could spread through the lunar dust, forever blurring the line between native conditions and human influence. Consider the implications for future exploration. Plans for lunar bases, mining operations, and long-term human presence are accelerating. Scientists must grapple with questions that were once theoretical. How can we prevent contaminating shadowed craters, ice deposits, and ancient lava tubes? What does it mean to explore responsibly when even a breath of Earth air could compromise unknown ecosystems? Or, in this case, the uncharted potential for life in dormant form. The Surveyor, 3-story, though debated, highlights the stakes. If microbes could survive on the moon for 2 years, what about decades? What about centuries? Could spores from Apollo missions in the 1970s still be lying dormant, waiting for the right conditions to awaken? The possibility stretches the imagination and forces a new perspective on our place in the solar system. Human footprints are visible and temporary, but microbes could be invisible and enduring, silently colonizing a world we once thought untouched. Scientists today are cautious but curious. Lunar sample return missions, robotic explorers, and strict planetary protection protocols aim to prevent further contamination while studying what might already exist. In essence, the moon is a dual laboratory, one for geological study and one for understanding the limits of life. By observing how microbes survive or fail in this alien environment, we gain insights into extremophiles, space biology, and even the potential for life on other worlds, such as Mars or the icy moons of Jupiter and Saturn. The narrative becomes even more tantalizing when we consider the hidden corners of the moon. Beneath the dusty surface lie lava tubes and shadowed craters, insulated from radiation and extreme temperature swings. Could these sheltered niches harbor microbial life, shielded from the sun's deadly rays? Could Earth's organisms, transported by humans decades ago, be quietly surviving in these lunar sanctuaries, untouched and unnoticed? The possibility is eerie, yet scientifically plausible. This raises questions that are as philosophical as they are scientific. What right do we have to introduce life to other worlds? How can we explore without erasing the very mysteries we seek to uncover? Forward contamination reminds us that even the smallest action, a fingerprint, a dropped tool, or a speck of dust, can have consequences that echo for centuries. Humanity, in its ambition to reach for the stars, is also shaping the destinies of other worlds, sometimes before we even understand them. But there is hope in this challenge. Awareness of forward contamination has led to stricter planetary protection measures. Space agencies now sterilize equipment, monitor microbial loads, and carefully plan missions to minimize human impact. Every lander, rover, and habitat must pass rigorous biological testing. In a sense, the moon becomes a teacher, reminding us that exploration is not just about conquering space, but about stewardship and humility. The silent lunar plains hold lessons for us, lessons in patience, foresight, and responsibility. And yet, the question lingers. What if we have already succeeded in introducing Earth life to the moon? What if the desolate craters and shadowed valleys harbor organisms we unwittingly brought decades ago? The answer may lie in future missions, advanced instruments, and perhaps even in lunar caves that await exploration. Each discovery will deepen our understanding of life's resilience and of humanity's unintended influence on other worlds. In the end, the moon is more than a stepping stone to Mars or a backdrop for human ambition. It is a mirror, reflecting our curiosity, our ingenuity, and our consequences. The microbes we may have left behind are whispers of Earth in a silent wilderness, a reminder that life, once it escapes the confines of our planet, is remarkably difficult to contain. And as humanity prepares to return in the coming decades, the question becomes urgent. Will we be mindful stewards, explorers, who respect the fragile balance of another world? Or will we repeat the mistakes of the past, leaving traces that future generations may discover as a puzzle, a warning, or a secret waiting to awaken in the lunar dust? The moon, once thought lifeless, now seems almost alive in its silent testimony. It challenges us to think beyond footprints and rocks, to consider the unseen passengers we carry, and to ask whether our reach for the stars is matched by wisdom and restraint. In the next chapter, we will journey even deeper into the moon's mysteries, exploring the possibility that it is not merely a repository for Earth microbes, but a keeper of ancient cosmic secrets, from hidden water ice to clues about the early solar system. Could the moon itself be a library of planetary history, waiting for humanity to read its story? The answers lie in its shadowed craters and ice-filled pits, beckoning us to explore further, with curiosity tempered by caution. Humanity's tiny footprint, the moon, glowing silently in the night sky, appears close, almost intimate. From Earth, it is a familiar companion, a constant witness to our history. Yet, despite decades of fascination and exploration, our presence on that pale, cratered surface is astonishingly minimal. For all our technological might, humanity has only ever brushed the moon's surface lightly, leaving a footprint here, a rover track there, mere whispers of existence on an immense alien landscape. Consider the Apollo missions. Between 1969 and 1972, 12 humans walked on the moon, each step meticulously recorded and celebrated as monumental achievements of human ingenuity. Yet if we measure it by distance, the scale is almost laughably small. Astronauts traversed less than 100 kilometers on foot across the entire lunar surface, a distance shorter than many modern marathons. Even with the lunar roving vehicles, which extended exploration a few kilometers beyond landing sites, the vast majority of the moon remained untouched. These missions were extraordinary, yes, but also intensely localized. Each landing site, a mere handful of square kilometers, represents a fraction of the moon's 38 million square kilometers of terrain. Step back and imagine the scale. The moon's surface stretches endlessly, craters overlapping like scars of cosmic battles, vast plains of basalt lava, jagged highlands, and shadowed valleys. Yet humanity has only lightly skimmed this surface. less than 0.001% has been visited by boots or wheels. The Apollo missions, celebrated as triumphs of exploration, remind us not of conquest, but of limitation. For all our power, the moon remains overwhelmingly mysterious. Its secrets lie waiting, just beyond the horizon, untouched and unknown. Robotic missions have extended our reach, but only slightly. Lunar orbiters, landers, and rovers have sent back incredible images, topographical maps, and scientific data. They've revealed swaths of lava plains, mountains, and cratered expanses, giving humanity the first real glimpse of the moon's intricate geography. Yet, these missions cover limited ground. Most robotic landers stay near equatorial regions for practical reasons: easier landing conditions, solar power availability, and communication with Earth. Polar regions, with their perpetual shadows and icy deposits, remain largely unvisited. Far side craters, hidden from Earth's gaze, are explored only by orbiters. Vast regions, perhaps the most scientifically rich, remain almost entirely unexplored. And what of the resources the moon may hold? Beneath the dust, the regolith, and the jagged rock formations lie deposits of minerals, metals, and potentially water ice, essential for future exploration. Yet these treasures are largely theoretical. The areas we've sampled directly are few, tiny islands in a vast lunar ocean. Every rover track, every soil sample, every photograph represents not mastery over the moon, but the beginnings of knowledge, tantalizing hints of what lies beyond our limited footprint. Even the landers themselves occupy vanishingly small space. Apollo modules touched down on gently sloping plains, carefully selected to minimize risk. They did not venture into jagged crater rims, frozen valleys, or shadowed cliffs. Lunar rovers extended the astronauts' reach, yet only by a few kilometers, leaving immense regions untouched, silent, and still. Meanwhile, the far side of the moon, perpetually hidden from Earth, has been visited only by orbiters and a handful of robotic landers in recent years. The landscape there is starkly different, older, more cratered, and geologically distinct from the near side, with fewer lava plains and more rugged highlands. Its secrets remain largely unread, awaiting a time when humans or advanced robotic explorers can venture into its lonely expanse. To put it in perspective, imagine an entire continent on Earth. Now imagine only the edges explored, the interior remaining untouched wilderness. That is the moon today. Every footprint, every rover track, is a reminder of how minuscule our presence truly is. Humanity, in its centuries of curiosity and technological advancement, has left only fleeting traces. The moon, vast and ancient, has hardly noticed us. Yet this tiny footprint carries enormous significance. Each Apollo rock sample, each rover photo, each spectrograph reading has revealed the moon's deep history, its violent origins, volcanic past, and relationship with Earth. Our brief visits have taught us about planetary formation, solar system evolution, and the delicate gravitational dance between our worlds. And yet, for all we have learned, the majority of the moon remains a closed book, its pages unturned. What stories might lie within craters unvisited, lava tubes unentered, or shadowed poles unlit by sunlight? The sense of scale and our relative insignificance also frames the moon as a frontier of imagination. It is easy to assume that because humans landed there, the moon is somehow known. But in truth, exploration is not conquest. Humanity's touch is light, almost imperceptible, a tiny signature on a world millions of kilometers away. Each mission is both an achievement and a reminder. For all our knowledge, for all our science, the moon remains vast, alien, and mysterious. This minimal footprint has profound implications for the future. As governments and private enterprises plan lunar bases, mining operations, and long-term human presence, they face the reality that much of the moon is uncharted. Every step into the unknown carries risks, from treacherous terrain to untested environmental conditions. Every mission into shadowed craters or deep lava tubes could reveal phenomena never before observed. Resources, hazards, or even hints of processes that have shaped the solar system itself. The opportunity is immense, but so too is the responsibility. Yet there is beauty in this limitation. The moon's silent, untouched expanses are reminders of wonder, of patience, and of discovery yet to come. Unlike Earth, with its crowded cities and mapped continents, the moon invites slow exploration, careful observation, and deep reflection. Humanity has glimpsed its surface, but we have not yet walked its wildest reaches, scaled its highest rims, or penetrated its deepest shadows. There is still room for awe, for mystery, and for discoveries that could redefine our understanding of worlds beyond our own. In essence, the moon is both familiar and alien. Its landscapes are known from photographs and orbital data, yet they are still largely unvisited, unread, unexplored. Humanity's footprint, small as it is, reminds us of the limits of our reach. And yet, it also points forward, to a future where that footprint may grow, cautiously, deliberately, and with the knowledge that each step leaves a mark not only on lunar soil, but on the story of human exploration itself. So, as we look up at that pale orb in the night sky, we must ask ourselves, what remains unseen? What remains untouched? What stories lie hidden in the miles of regolith beyond our brief footprints and rover tracks? And how will humanity ensure that our expansion into these silent territories is guided not by haste or greed, but by curiosity, care, and reverence for a world that has watched us from afar for billions of years? The moon, in its vastness, reminds us of the enormity of the universe, the smallness of our footprint, and the endless frontier that awaits. Its untouched regions beckon to the explorers of tomorrow, scientists, astronauts, dreamers, inviting them to tread carefully, observe deeply, and uncover secrets that could forever change our understanding of Earth, the moon, and the cosmos. And as we prepare to step beyond our tiny footprint, the next chapter will explore what lies beneath the surface. Hidden resources, ice deposits, and mysterious lava tubes that could hold not just water, but the keys to humanity's future on the moon. Could these underground networks be the gateways to permanent lunar habitation, or the repositories of untold cosmic secrets? The answer awaits, buried just beneath the dust. Lunar trash, a museum of human presence. When we gaze up at the moon, it seems pristine, untouched, a glowing sentinel in the night sky, ancient and unchanging. But look closer, and the story changes. Beneath its tranquil surface lies a secret. Humanity has left a permanent mark, not just in footprints, but in debris, relics, and remnants of our earliest journeys beyond Earth. The moon has become, in essence, a museum of human activity, a silent archive of exploration, ingenuity, and perhaps carelessness. Since the first tentative Apollo missions in the late 1960s, humans have been leaving more than footprints and flags. Lander modules, discarded tools, rover parts, cameras, and even personal waste have accumulated over decades. Scientists estimate that over 200 tons of human-made material now rests on the lunar surface. That's heavier than many school buses, scattered across dozens of landing sites, quietly enduring the vacuum of space and the ceaseless battering of micrometeoroids. Consider the Apollo 11 mission, the first to carry humans to another world. Beyond Neil Armstrong's first steps and the iconic planting of the American flag, the crew left behind backpacks, empty food containers, experimental equipment, and a plaque commemorating the moment. On subsequent missions, the accumulation grew. Lunar rovers abandoned at the end of their journeys, tools left behind to save weight for the return voyage, even cameras and film canisters. Each item tells a story, a snapshot of human ambition, frozen in time. And then there is Surveyor 3, an unmanned lander from the 1960s, which was visited years later by Apollo 12 astronauts. Its metal structure, once functional, now lies exposed to the harsh lunar environment, a reminder that even the most advanced human creations are temporary on an alien world. Yet these relics are more than mere trash. They are historical artifacts, evidence of humanity's first tentative steps into space. Some of it is strange, even whimsical. Flags stand erect in the dry lunar soil, their colors frozen against time, yet bleached and tattered by solar radiation. Plaques commemorate humanity's presence, yet silently, they also mark the permanence of human impact. Even waste, like bags of urine and fecal matter left behind to save cargo weight for the astronauts' return journey, rests on the lunar surface as an unintentional testament to the practical challenges of living beyond Earth. The moon has become a mirror, reflecting both our curiosity and our imperfections. This accumulation raises a profound question. How do we treat this alien museum? Should humanity preserve these artifacts for future generations, a record of our first steps beyond the cradle of Earth? Or should we clean up, removing debris to protect the moon's environment and preserve it for future exploration? The debate is far from simple. Preservationists argue that lunar trash is a chronicle of human history, a physical archive that no photograph or video can truly replace. Every rover track, every discarded tool, every lander is a time capsule. They speak to ingenuity, bravery, and the triumph of exploration. They tell the story of a species that dared to leave its home planet and touch another world. Destroying or removing these items, some argue, would be akin to demolishing the pyramids or erasing the first footprint in the sand. On the other hand, cleanup advocates highlight the ethical responsibility we carry. The moon, though not alive in the traditional sense, is a pristine environment. Human debris, metallic components, chemical residues, and waste interacts with its fragile surface, introducing changes that are effectively permanent. Future explorers could inadvertently contaminate experiments designed to detect lunar resources, a water ice, or even potential microbial life. In this view, leaving debris behind is a form of environmental neglect, a footprint that humanity might someday regret. Then there is the scientific dimension. Lunar archaeologists, if one might call them that, are increasingly interested in these artifacts themselves. The moon's vacuum preserves objects far better than Earth's atmosphere ever could. A camera left on the lunar surface decades ago may still contain functional components, unchanged by oxidation or corrosion. Soil samples collected near landers hold traces of human activity, chemical signatures of rocket exhaust, and even dust stirred by rover wheels. In this way, the debris is not just historical, it is scientific. It offers insights into the interaction between technology and the lunar environment, lessons critical for the next wave of exploration. And yet, the moon's story is not static. Micrometeorite impacts, extreme temperature fluctuations, and the constant bombardment of cosmic radiation slowly erode these artifacts. Flags fade, metal corrodes under relentless cosmic rays, and tracks eventually fill in with shifting regolith stirred by tiny impacts. The moon is a patient archivist, silently recording humanity's presence while slowly reclaiming it. Our marks are permanent, yet not eternal. Visible today, but destined to fade into the lunar landscape over centuries and millennia. This duality, the moon as both a record and a reclaiming force, reflects the broader tension in humanity's approach to space. We arrive, we leave traces, and we must decide whether to honor, protect, or erase them. Each mission, each footprint, each discarded tool becomes a symbol, not just of exploration, but of our values and priorities as a species. There is also a poetic element in this story. Imagine standing on the lunar surface, centuries from now, gazing at the remnants of Apollo missions. Future explorers, perhaps robots, perhaps humans, might uncover a weathered rover, a plaque, or even a tattered flag. These artifacts, relics of our first daring steps into the cosmos, could inspire wonder, reflection, or even humility. The moon, silent and indifferent, preserves a narrative that is uniquely human: triumph, curiosity, and the stubborn desire to reach beyond our world. And yet, this narrative is unfinished. Lunar trash is not just history, it is a bridge to the future. As nations and private companies plan permanent settlements, mining operations, and lunar bases, our footprint will grow. The decisions we make now, whether to preserve or remove, whether to respect or exploit, will set the tone for humanity's relationship with all other worlds. The moon is our first laboratory, our first archive, our first museum of interplanetary presence. How we treat it may define the ethics of our species for centuries to come. So, the moon is both familiar and alien, pristine yet marked, timeless yet undeniably shaped by human hands. Its surface is littered with stories of courage, mistakes, ingenuity, and the stubborn persistence of life reaching beyond its home planet. Every module, every tool, every rover track is part of a narrative that stretches from the 1960s to the present day, whispering questions to anyone willing to look. How will we honor this legacy? How much do we leave behind? And how much do we take with us into the next era of exploration? And as we prepare to look beyond these artifacts, the next chapter will guide us into the moon's hidden depths. Beneath the dust and debris lie vast networks of lava tubes, potential ice reserves, and subterranean mysteries that may hold the key to long-term human presence. The surface tells one story, the visible record of human ambition, but below, a silent, shadowed world awaits, full of promise, danger, and secrets yet to be revealed. The future of tidal locking. Look up at the night sky, and the moon appears constant, familiar, unchanging. We see the same face every night, as if the moon itself is gazing back at us, silently observing the earth. But this calm exterior conceals a slow, inexorable dance, a cosmic rhythm that has been playing out for billions of years and will continue far beyond our own existence. This is the story of tidal locking, of invisible forces that bind a planet and its satellite in a gravitational embrace, and the far-reaching consequences it may hold for the distant future. Tidal locking is a subtle, almost imperceptible phenomenon. It occurs because gravity, that invisible tether connecting Earth and the Moon, exerts unequal forces across the bodies it links. Imagine the Moon tugging on the oceans, drawing them into elongated bulges. These tidal bulges are not perfectly aligned. The Earth rotates slightly faster than the Moon orbits. This tiny misalignment generates friction, transferring rotational energy from Earth to the Moon. Over eons, the Moon drifts outward, inch by inch, while the Earth's rotation slows. The day lengthens imperceptibly, and the Moon moves farther away, a silent passenger in an endless gravitational waltz. Today, the Moon completes a rotation in exactly the same time it takes to orbit Earth, about 27.3 days, forever presenting one face to us. But this locked orientation is only the beginning of a much grander story. For billions of years, the same forces will continue their subtle work. The Earth itself is gradually slowing down, the days growing longer as the Moon drifts farther into the void. In a distant future, some scientists speculate that the Earth could become tidally locked to the Moon as well, presenting only one face toward it, just as the Moon does to us now. Imagine a planet frozen in perpetual alignment, one hemisphere bathed in the light of a bright satellite, the other hidden in eternal shadow. What would life be like under such conditions? How would winds, oceans, and climates evolve under a sunlit side and a shadowed one? This cosmic rhythm is not violent or immediate. It is imperceptible in a human lifetime. Lunar laser ranging experiments, conducted since the Apollo missions left mirrors on the Moon, show that the Moon is moving away at a rate of approximately 3.8 centimeters per year. That's about the width of a fingernail annually, barely noticeable, yet inexorable over geological timescales. Each year, Earth loses a fraction of its rotational speed, subtly lengthening the day. It is a quiet, relentless transformation, an example of how even seemingly fixed celestial bodies are in constant motion. But what happens if we expand this timeline into the distant future? Tens of billions of years from now, long after the Sun has begun its final stages, the Earth-Moon system could become completely synchronized. Both bodies rotating at the same rate, locked in a cosmic stare, orbiting a dying sun. Tides would become permanent features, no longer rising and falling, but frozen, etched into the surface as silent reminders of past motion. Ocean currents, long driven by tidal forces, might stall, altering the dynamics of climate and geology. Even the day-night cycle, a fundamental rhythm of life on Earth, could vanish entirely, replaced by a static, unchanging environment. Of course, these distant scenarios are largely theoretical. Billions of years is a timescale almost impossible to truly grasp. Civilizations rise and fall, stars are born and die, and yet the gravitational conversation between Earth and its Moon continues, unaffected by human ambition or neglect. It is humbling to realize that while humanity dreams of colonizing the Moon or Mars, the real drama of planetary evolution unfolds over incomprehensible stretches of time, indifferent to our fleeting presence. Tidal locking is also a lens through which we can understand other planetary systems. Exoplanets discovered orbiting distant stars often display signs of similar phenomena. Many are tidally locked to their parent stars, with one hemisphere scorched by relentless sunlight, the other frozen in darkness. Could life adapt to such extremes? Could an ecosystem arise under eternal daylight or perpetual night? By studying our Moon, we gain a window into the broader cosmos, a natural laboratory for understanding the rhythms and limits of planetary evolution. But the story grows even more fascinating when we consider hypothetical cosmic interactions. The moon's outward drift could someday lead it to a point where gravitational resonances with the sun or other planets subtly alter Earth's orbit. These perturbations could affect everything from the length of the year to the stability of the axial tilt, which governs the seasons. While the details are highly speculative, they remind us that tidal locking is not a static phenomenon. It is part of a dynamic, interconnected celestial ballet. Every pull, every bulge, every fraction of a rotation contributes to a cosmic choreography that stretches far beyond human comprehension. And yet, in the present, the effects are already tangible. Astronomers can measure the slowing of Earth's rotation in fossil records, observing ancient coral growth patterns and tidal rhythmites that preserve the memory of days hundreds of millions of years long. These records remind us that tidal friction is not a distant curiosity. It has shaped the Earth's geological history, influencing climate, ocean circulation, and even the evolution of life. The slow lengthening of days has altered the environment in ways that shaped the rise of complex organisms. In essence, the moon's gravitational pull has been an invisible architect of life itself. Consider this. Every time you glance at the moon, it is not merely a passive satellite. It is an active participant in the story of our planet, a force that has slowed our rotation, molded our tides, and will continue to do so for eons. The moon is both partner and sculptor, quietly shaping the conditions for life while remaining a constant companion in our night sky. Its influence is a reminder that even the most familiar celestial objects are dynamic, their apparent stillness deceiving. As we contemplate tidal locking, we are also invited to think about impermanence and scale. Human lifespans, cities, even entire civilizations are fleeting compared to the timescales of celestial mechanics. Yet our curiosity, our desire to understand, allows us to glimpse the slow choreography of the universe. We can watch, measure, and imagine a future billions of years hence, long after we are gone, when the Earth and Moon may be locked in a perfect, eternal gaze. This perspective is humbling, yet strangely comforting, a reminder that we are part of a larger ongoing cosmic story. And as the moon drifts ever outward, as the days lengthen and the tides slow, we are left with a question both scientific and philosophical. What does it mean to be a species aware of such slow, inexorable forces? We may not witness the final tidal lock, but understanding it connects us to the universe in a profound way. It reminds us that our world, as familiar as it seems, is never truly static. It is alive in ways we can only measure through patience, imagination, and the relentless laws of physics. The future of tidal locking is, ultimately, a meditation on time, gravity, and cosmic inevitability. It challenges us to see the moon not just as a distant object in the sky, but as a participant in a billion-year-long story, one that has shaped life, climate, and the very rotation of our planet. And while this story may unfold over timescales beyond our comprehension, it invites us to look beyond immediate concerns, to think about the forces that govern worlds, and, perhaps, the lessons they hold for our own place in the universe. As night falls and the familiar face of the moon rises once more, we are left to wonder. Billions of years from now, what will Earth and its lunar companion look like? Locked in a silent, eternal dance, each watching the other across the void. And beyond this, deeper mysteries await. not just on the surface, but within the moon itself. Vast subterranean chambers, frozen reservoirs of ice, and secrets that may one day sustain human life far from Earth. The next chapter beckons us into these shadowed depths, where the moon's hidden landscapes hold both promise and danger, waiting for the first explorers to step inside. Returning to the moon, Artemis and beyond. For half a century, the moon has been a silent witness to humanity's ambitions. Its cratered surface has stared back at us, untouched, except for the footprints of a few brave explorers. But now, after decades of absence, humanity is preparing to return. Not just for fleeting visits, but to stay, to build, to explore, and perhaps even to transform the lunar landscape. The stage is set for a new era, Artemis and the promise of lunar colonization. NASA's Artemis program is the boldest attempt yet to reclaim the moon as a human frontier. Named after the twin sister of Apollo, Artemis carries forward the legacy of the original missions while looking toward a future of sustainability. Artemis III, the centerpiece of the program, will land astronauts near the moon's south pole, a region shrouded in mystery and bathed in near-perpetual light. Unlike the familiar sun-bleached plains of the Apollo landing sites, the lunar South Pole is a landscape of extreme contrasts: shadowed craters, frozen reservoirs of water ice, and ridges illuminated by sunlight almost constantly, perfect for solar power. It is here, in these hidden and luminous corners, that humanity hopes to establish its first sustainable foothold beyond Earth. Water ice, once thought impossible on the moon, is now recognized as one of the most valuable treasures hidden in its shadowed craters. Imagine the implications: a source of drinking water, breathable oxygen, and, crucially, hydrogen and oxygen for rocket fuel. Water becomes more than a scientific curiosity. It is the key to survival, mobility, and expansion. The moon is no longer just a destination. It is a potential launch pad for the rest of the solar system. And to harness these resources, Artemis will deploy life support systems, habitats designed to shield humans from radiation, extreme temperatures, and the Artemis vacuum of space. These habitats will not just be shelters. They will be miniature worlds, complex ecosystems in which humans must thrive under alien skies. But NASA is not alone in this lunar renaissance. Private companies, once relegated to the margins of space exploration, are now shaping the future of humanity on the moon. SpaceX envisions Starship missions, carrying heavy cargo and crews to lunar orbit and beyond, acting as a bridge between Earth and the deep cosmos. Blue Origin, with its Blue Moon lander, imagines a fleet of spacecraft ferrying materials and equipment to support sustained lunar settlements. Even smaller enterprises like Astrobotic are pioneering robotic landers and rovers, mapping the surface, scouting landing zones, and delivering payloads with precision. Together, these public and private endeavors form a tapestry of ambition, each thread pulling humanity closer to a permanent lunar presence. The Artemis program is not merely about planting flags or taking photographs. It is about survival, adaptation, and preparation. Solar energy will light the bases, powering experiments, life support systems, and communication arrays. Regolith, the moon's fine, dusty soil, will be used for construction, shielding habitats from radiation and micrometeorites. Even the smallest craters and crevices hold secrets that could influence habitat design. Underground lava tubes, large enough to shelter entire colonies, offering natural protection and stable temperatures. Every step, every landing, every experiment is a rehearsal for the greater journey beyond the moon. Yet, as humanity prepares to return, there is an undeniable tension. The moon has long been a place of symbolic unity, a shared celestial neighbor for all nations. How do we balance exploration with preservation? How do we ensure that these historic sites, scattered with Apollo artifacts and scientific instruments, remain intact amidst the rush of rockets and rovers? Artemis carries not just astronauts, but the weight of responsibility, ethical, historical, and environmental, toward the first off-world landscapes humanity ever touched. The South Pole's frozen reservoirs, in particular, represent both promise and peril. Water ice is essential for life and fuel, but it is also fragile, buried in shadows for billions of years. Every excavation, every mining operation risks altering a landscape that has remained pristine since the moon's earliest days. Scientists and engineers are tasked with a delicate dance: extract resources, establish settlements, and experiment with lunar technologies, all while treading lightly on an alien world whose history is older than any human civilization. Beyond survival, the moon is a laboratory for the future of space travel. Artemis is a proving ground for the technologies that will eventually take humans to Mars and the outer planets. Long-duration habitats, closed-loop life support, energy storage, contaminate, and sustainable food systems, all tested under the moon's low gravity and harsh environment, will inform missions far beyond the Earth-Moon system. In this sense, the moon is not an endpoint. It is a gateway, a stepping stone to a future where humanity may live among the stars. But Artemis also inspires reflection. Why return to the moon after decades? Because in those decades, humanity has gained new eyes. Satellites have mapped its surface in exquisite detail. Robotic explorers have uncovered ice in permanently shadowed craters high-resolute. Ion imaging reveals boulder-strewn plains, deep rills, and lava tubes that may shelter future colonies. Each discovery rekindles a sense of wonder and an awareness that the moon, though familiar, is far more complex and dynamic than the desolate landscape captured in Apollo-era photographs. And the implications are profound. As we approach the moon, not as tourists, but as settlers, we must ask ourselves, what kind of presence will humanity leave? Will we tread lightly, respecting a celestial companion that has silently guided Earth's tides and inspired human imagination for millennia? Or will we transform it into a utilitarian outpost, a mere stepping stone toward Mars and beyond? The answer is uncertain, but the choices made during Artemis will set precedents for centuries of exploration. As astronauts prepare to descend toward the icy craters of the South Pole, the moon becomes more than a distant orb in the night sky. It is a laboratory, a resource depot, a testing ground, and a mirror reflecting humanity's ambitions and ethics. It reminds us that the age of lunar exploration is not just about footprints or flags, but about systems, sustainability, and the delicate interplay between curiosity and responsibility. And yet, even as we plan our return, mysteries remain. Beneath the surface lie vast networks of lava tubes, ancient channels carved by volcanic flows, potentially spanning kilometers and untouched since the moon's fiery youth. These subterranean corridors could shelter water ice, preserve remnants of the lunar interior, and perhaps even serve as refuges for humans against radiation and meteor strikes. Artemis may be the key that unlocks these hidden chambers, But what other secrets lie buried, waiting to challenge our understanding of the moon and its place in the cosmos? As the countdowns begin, rockets ignite, and humanity prepares to once again set foot on the lunar surface, we are reminded that exploration is never just about the destination. It is about the questions we ask, the technologies we develop, and the new perspectives we gain on our own planet and its celestial companion. The moon is no longer a symbol of a fleeting triumph in the 20th century. It is the first chapter of a new era, one that will shape the future of humanity in space. And as Artemis and the private explorers push the boundaries of the familiar, our gaze must inevitably shift further outward. The moon may be the first step, but Mars and the outer planets beckon with even greater mysteries. Every rover tracks the surface, every habitat experiment unfolds, and every frozen crater holds the potential to sustain life far from Earth. The story of humanity's return to the moon is, in truth, a story of ambition, caution, and curiosity, a prelude to the next great leap into the cosmos. In the end, as the lunar horizon glows softly with reflected sunlight, the moon challenges us to look beyond what is visible, to imagine what is possible, and to prepare for journeys that stretch beyond the human lifespan. Artemis is more than a program. It is a promise that the moon, long a silent observer, may soon become a partner in our exploration of the universe. And beyond this partnership lies a deeper mystery, hidden in shadowed craters and ancient lava tubes, waiting for the first explorers to step into the unknown. Colonizing the moon, challenges and risks. The idea of humans living on the moon has long lingered in our imagination, from science fiction novels to the bold visions of space agencies. But the reality of colonization is far more complex than the simple act of stepping onto its surface. The moon is beautiful, silent, and alluring, but it is also an environment of extremes, a harsh world that tests the limits of human survival. Radiation, micrometeorites, abrasive dust, and profound isolation are not abstract obstacles. They are daily realities that any lunar inhabitant would face. Radiation is one of the moon's most insidious dangers. Without a protective atmosphere or magnetic field, cosmic rays and solar flares bombard the surface relentlessly. Prolonged exposure can damage DNA, increase cancer risks, and compromise the health of anyone venturing outside a habitat. On Earth, we are cocooned in layers of air and magnetism that filter these invisible threats. But on the moon, radiation is a constant companion. Every wall, every habitat module, every suit must be designed to withstand it. And then there are micrometeorites, tiny fragments of rock and metal traveling at tens of kilometers per second. Though minuscule, they strike with immense energy, capable of puncturing unprotected structures and equipment. The lunar environment, once perceived as peaceful and still, is actually a battlefield of cosmic debris, invisible yet potentially lethal. Perhaps the most deceptively mundane hazard is the moon's dust. Lunar regolith is unlike anything on Earth, fine, jagged, and highly adhesive. It clings to everything, spacesuits, tools, and even electronics. Apollo astronauts described it as like powdered glass, a persistent irritant that can damage machinery, abrade surfaces, and pose respiratory risks. Over time, dust could degrade solar panels, clog airlocks, and infiltrate habitats, turning daily life into a continuous battle against an alien powder. Isolation is another silent challenge. On Earth, Even in remote research stations, help is always hours or days away. On the Moon, assistance is measured in weeks, and communication delays add layers of complexity. Lunar inhabitants must be psychologically resilient, able to navigate solitude and confinement, and capable of managing emergencies independently. Life on the Moon is not just a physical test. It is a test of the human mind, a confrontation with the vast emptiness that surrounds a celestial body no larger than a continent. To meet these challenges, engineers and scientists are exploring innovative habitats and infrastructure. 3D printing technology, using lunar regolith itself as raw material, could construct protective walls, shelters, and even entire buildings directly on the surface. Imagine automated machines, powered by solar arrays, extruding layers of dust and molten rock into walls capable of shielding humans from radiation and meteorites. Then there are lava tubes, ancient cavernous tunnels carved by volcanic activity billions of years ago. These underground networks may offer natural protection from the Moon's harsh conditions, providing stable temperatures, shielding from radiation, and ready-made structures for long-term habitation. Modular infrastructure will be essential for the Moon's first settlements. Habitats must be expandable, transportable, and self-sufficient. Each module will serve multiple functions: living quarters, laboratories, power stations, greenhouses, and storage. The challenge is not just to survive, but to thrive. In a place where every resource must be meticulously managed, redundancy and adaptability are crucial. Closed-loop systems, recycling water, oxygen, and even waste, will be the lifeblood of lunar colonies. Food may initially be transported from Earth, but hydroponics, aeroponics, and eventually in situ cultivation could provide a measure of independence. Every drop of water, every gram of air, and every electron of energy will be precious, a testament to human ingenuity in a world with no margin for error. Logistics are another monumental hurdle. Transporting materials, equipment, and people between Earth and the Moon is costly and complex. Each launch must be meticulously planned, with contingencies for equipment failure, weather, and orbital dynamics. Supplies may be pre-positioned for months or years, meaning lunar pioneers must live off carefully rationed reserves. Even a minor miscalculation could compromise an entire mission. In this sense, colonizing the Moon is not just a technological challenge. It is an orchestration of planning, precision, and patience, spanning hundreds of thousands of kilometers through space. But what of the long-term vision? Could research stations eventually evolve into a true lunar civilization? If the first outposts prove sustainable, the possibility emerges of self-sufficient colonies, complete with permanent residence, governance structures, and even social systems. Legal and ethical questions quickly come into play. The Outer Space Treaty forbids sovereignty claims. Yet, as humans begin to inhabit the Moon, who decides resource rights, land use, or environmental protections? How do we balance private enterprise ambitions with the idea of space as a shared heritage? The Moon, once a blank canvas, will become a stage for human organization, ethics, and law, a reflection of our species' ability, or inability, to coexist responsibly beyond Earth. Technologies being developed today are shaping that future. Life support systems capable of filtering and recycling air, water, and waste are already in prototype stages. Solar farms on ridges that bask in near-constant sunlight could power habitats indefinitely. Robotic assistance and autonomous construction systems may pave the way before humans arrive, assembling structures, preparing landing sites, and ensuring that the first settlers step into a functioning environment. Yet each advancement comes with risk. Mechanical failures, system malfunctions, and unforeseen lunar conditions can quickly escalate from inconvenience to catastrophe. Psychology, too, will be tested. Lunar pioneers will live in small communities, often confined within a few hundred square meters, under constant surveillance of life support systems. Social cohesion, mental health, and teamwork will be as critical as oxygen and water. Every disagreement, every misstep, carries amplified consequences in an environment where evacuation is not an option. Humanity's first steps toward colonization will not just test machines. They will test the very limits of human resilience, creativity, and cooperation. Despite the dangers, the allure is undeniable. The moon offers not only scientific discovery, but the potential to reshape humanity's relationship with the cosmos. It could serve as a platform for astronomy, a laboratory for planetary science, and a proving ground for technologies that will one day carry humans to Mars and beyond. Every challenge surmounted on the moon, radiation, isolation, dust, logistics, will be a rehearsal for the grand experiment of life beyond Earth. Yet even as we imagine these settlements, mysteries linger. Beneath the surface lie untapped reserves, unknown geological structures, and perhaps secrets from the moon's earliest epochs, frozen in time. Lava tubes could shelter not only humans, but evidence of processes that shaped the inner solar system. Water ice, preserved in darkness for billions of years, may hold clues to the history of Earth's companion. Colonization is not merely about survival. It is about discovery, curiosity, and the careful unraveling of ancient cosmic stories. Ultimately, colonizing the moon is an exercise in humility as much as ambition. It forces us to confront our limitations, to plan meticulously, and to respect an alien world. The moon is more than a stepping stone. It is a teacher, a reminder that the universe is vast, indifferent, and filled with challenges we are only beginning to understand. And as humanity contemplates a permanent presence, we must ask ourselves, what will we leave behind? Will it be footprints and trash, or knowledge, sustainability, and wonder? As the first habitats rise, as rovers traverse craters in search of water and resources, the moon will transform from a silent observer to a participant in human history. And yet, as we lay the foundations for life beyond Earth, one question looms larger than any technical challenge. What will it mean to truly call another world home? And as lunar colo, knees begin to grow, with humans learning to live, work, and survive on our nearest celestial neighbor, the next frontier beckons. Mars. If the moon is a testing ground, then the red planet is the ultimate challenge, a world that will test everything we learn on the moon, and then push us even further into the unknown. The moon as a geopolitical chessboard. The moon has always been a silent witness to humanity, orbiting above us in quiet, eternal vigilance. Yet, in the 21st century, it has begun to emerge not merely as a celestial body, but as a stage for terrestrial power struggles. The quiet lunar landscape is slowly transforming into a geopolitical chessboard, where nations, alliances, and private corporations maneuver in shadows, vying for influence, resources, and strategic advantage. The modern lunar race is not the story of a single country or a single mission. It is a complex, multifaceted contest. The United States, through NASA's Artemis program, seeks to reassert its presence on the moon with Artemis III, and a network of outposts, orbital gateways, and research stations. China, with its Chang'e program, has already landed on the far side, collected samples, and launched ambitious plans for a permanent lunar research facility in collaboration with Russia. India, Europe, Japan, and emerging spacefaring nations are quietly building their own capabilities, sending orbiters, landers, and rovers, each with an eye on the moon's untapped potential. Even private companies, SpaceX, Blue Origin, Astrobotic, are staking claims, bringing commercial speed and innovation into what was once a strictly governmental domain. On the surface, it might look like scientific exploration, but underneath lies the unmistakable pulse of geopolitics. The Artemis Accords, signed by multiple nations, set forth principles for responsible lunar activity: transparency, peaceful purposes, avoidance of harmful interference, and the sharing of scientific data. At the same time, China and Russia's International Lunar Research Station represents a parallel vision of lunar development, one that emphasizes sovereign collaboration outside of the Artemis framework. Two distinct visions, two different philosophies, competing silently in craters and basins that humans have yet to fully explore. Why does the moon matter so intensely? The answer is hidden in its ice, rocks, and regolith. Water ice, trapped in permanently shadowed craters near the poles, is more than a scientific curiosity. It is a lifeline for future colonies, a source of drinking water, breathable oxygen, and even rocket fuel. Helium-3, a rare isotope embedded in the lunar soil, has been touted as a potential fuel for future fusion reactors, promising energy on a scale Earth can only dream of. And beneath the surface may lie rare minerals, tantalum, platinum group metals, and other elements critical for high-tech industry. On a barren, airless world, these resources are concentrated and accessible, but their value is immense, and that creates friction. This is where legal gray areas blur the line between cooperation and competition. The Outer Space Treaty of 1967 prohibits sovereignty claims, ensuring that no nation can officially own the moon. Yet it does not prevent the extraction of resources, nor does it clearly define how they should be shared. Could a nation or corporation claim ownership over a crater rich in ice? Could private mining operations become the equivalent of colonial enclaves in space? The answers are not written in law. They are being negotiated in real time, through diplomatic channels, public statements, and quiet maneuvers in orbit. Territorial ambiguity fuels tension. A lunar base may appear innocuous, a cluster of solar panels and a habitat module, but its implications are profound. Location matters. The South Pole, with its water ice and near-constant sunlight, is a prize. Near-side and far-side differences are more than scientific curiosities. They are strategic considerations. Nations may race to establish outposts in key locations, not just for research, but to secure access to resources, communication advantages, or potential staging areas for deeper space exploration. Each robotic rover, lander, or astronaut sets a subtle marker in this emerging map of influence. The geopolitical dimension of the moon is not limited to nations. Private enterprises bring both innovation and unpredictability. SpaceX's reusable rockets could make transport faster and cheaper than ever before. Blue Origin envisions orbital fuel depots and lunar landing modules. Companies like Astrobotic and iSpace aim to commercialize resource extraction. With private funding and rapid iteration, they can act faster than governments, but they also introduce a layer of complexity. Who regulates them? How are their activities reconciled with international treaties? And if they claim a mining site, do they spark a silent conflict with state-backed competitors? The lunar chessboard is not only populated by nations, it is shared with corporations whose ambitions may rival or even outpace those of states. Science and strategy intertwine in this new lunar era. Robotic scouts may map ice deposits while simultaneously observing potential rival activity. Habitats may serve as both research centers and strategic footholds. Even the seemingly mundane act of drilling or landing could carry geopolitical weight. Every decision, every experiment, every transmission from the lunar surface sends ripples through governments, corporations, and alliances back on Earth. The Moon, once a symbol of human wonder and exploration, now mirrors the complex realities of Earth's diplomacy, economics, and competition. Yet there is a subtle paradox at play. The Moon is both a shared heritage and a prize to be won. The same ice that sustains life for astronauts could become a flashpoint between nations. The same minerals that power Earth's technologies could ignite silent disputes hundreds of thousands of kilometers away. How do we balance cooperation and competition in an environment where miscalculation could not only endanger a mission, but spark diplomatic crises? Lunar geopolitics forces us to confront questions we rarely consider on Earth. What is the ethical way to share resources on another world? Can humans avoid repeating the mistakes of history on a blank celestial canvas? The stakes extend far beyond the Moon itself. Establishing influence here could determine leadership in the wider solar system. A nation or corporation with advanced lunar capabilities may gain first access to Mars, asteroids, and even Jupiter's moons. Lunar presence becomes a testing ground, a proving ground, and a prelude to interplanetary strategy. The first movers on the Moon are not merely exploring. They are shaping the future balance of power in a universe where humans are just beginning to leave the cradle of Earth. Despite these tensions, there are glimmers of hope. International collaboration is possible, as demonstrated by the partnerships on the International Space Station. Scientific data can still be shared, missions can be coordinated, and safety protocols enforced. Yet such cooperation is fragile, constantly threatened by ambition, secrecy, and competition. The Moon, in its silent orbit, watches patiently as humanity navigates these treacherous waters, indifferent to disputes, yet shaping our behavior through the stark reality of survival and opportunity. The geopolitical lunar game is only beginning. Craters that once lay untouched for billions of years are now becoming arenas of influence. Rovers, landers, and habitats are more than instruments of science. They are pieces on a cosmic chessboard. Every strategic choice, every alliance, forged or broken, every claim made or avoided, writes a story of ambition that is both timeless and immediate. And as nations and corporations race to claim, explore, and utilize the Moon, one truth becomes clear. The Earth's nearest neighbor is no longer just a destination. It is a proving ground, a crucible for diplomacy, and a mirror reflecting humanity's drive for power, knowledge, and survival. The Moon may appear silent, but it is alive with human ambition, poised at the center of a drama that could define the next century of space exploration. As lunar geopolitics intensifies, the question remains: will humanity treat the Moon as a shared legacy, or will it become a contested prize, fractured by rivalry and ambition? And beyond that horizon, past political borders and territorial disputes, lies the ultimate challenge: Mars, the outer planets, and the boundless expanse of the cosmos. The game we play on the moon is only the opening move in humanity's interplanetary story, and the next chapters promise risks, discoveries, and mysteries that dwarf even the grandest ambitions of the present. The moon as a mirror of humanity. From Earth, the moon seems eternal, serene, and distant, an unchanging sentinel in the night sky. For millennia, humans have gazed upon it with wonder, curiosity, and reverence. Poets have written of its pale glow. Scientists have charted its craters and plains. Dreamers have imagined stepping onto its dusty surface. Yet, in the modern age, the moon has become more than a celestial object. It has transformed into a mirror, reflecting not only our ambitions, but our politics, our ethics, and our very nature as a species. The story of the moon is inseparable from the story of humanity. Each footprint left by Apollo astronauts, each robotic lander traversing its surface, is more than a scientific milestone. It is a testament to human daring, ingenuity, and sometimes our hubris. The lunar landscape captures our triumphs and foibles in equal measure. Left behind are modules, rovers, flags, and even discarded tools, our artifacts frozen in time, a quiet archive of humanity's earliest steps beyond Earth. They are symbols of exploration, but also of our tendency to leave traces, to imprint ourselves wherever we go, for better or worse. Science has always driven our relationship with the moon. From the first telescopic observations to the precise laser-ranging experiments still ongoing today, we have sought to understand its origin, composition, and orbit. Each mission, whether crude or robotic, expands our knowledge, revealing a world both alien and intimately connected to Earth. The moon is a laboratory in microgravity, a record keeper of cosmic history, and a testing ground for technologies that may one day carry us to Mars and beyond. In studying it, we discover not only its secrets, but the limits and possibilities of human endeavor. Yet the moon also reflects something deeper, our ambitions, both individual and collective. The Cold War, for instance, transformed lunar exploration into a stage for political rivalry. The space race was not merely about rockets and landing modules. It was about demonstrating technological superiority, national pride, and ideological dominance. Apollo's triumphs were celebrated worldwide, but they were also part of a broader struggle, a projection of earthly conflict onto a celestial canvas. In that sense, every crater visited, every soil sample returned, carries a dual narrative, one of science and one of human drama. Today, the ambitions are more complex, but the pattern remains. Nations and corporations race to the moon, seeking water ice, rare minerals, and strategic footholds. Legal frameworks attempt to mediate, treaties attempt to regulate, yet the underlying human drive remains unmistakable. We want to leave a mark, to claim achievement, and to extend our influence beyond Earth. Even as we speak of collaboration and shared knowledge, competition and strategic interests quietly guide decisions. The moon, in its silent orbit, watches as we project our desires, fears, and rivalries onto its surface. But the moon does more than reflect politics. It mirrors our ethics. As we plan for lunar bases, mining operations, and long-term habitation, we are forced to confront questions that are rarely asked in the rush of technological progress. How should we interact with a world that is not ours to own, yet which holds potential for immense gain? What obligations do we have to preserve its scientific value, its beauty, and its history? Every habitat module, every lander, every drill hole is a decision with moral weight. The moon becomes a canvas for experimentation, not only in science, but in stewardship, responsibility, and foresight. Humanity's expanding footprint on the moon also reflects our collective imagination. From 1969's first steps to Artemis and commercial ventures today, the surface of the moon has transformed from a distant dream into a reachable frontier. And yet, when compared to its vast expanse, our presence is almost negligible. Apollo astronauts traversed fewer than 100 kilometers on foot. Robotic explorers have sampled only select regions. Vast plains, hidden craters, and shadowed polar valleys remain untouched, rich with geological clues and resources. In this way, the moon mirrors both our audacity and our limitations. We dream boldly, but act cautiously, constrained by technology, resources, and knowledge. As we contemplate long-term habitation, the moon becomes a reflection of our adaptability and ingenuity. Closed-loop life support systems, 3D printed habitats, and radiation shelters are not only technical solutions, they are symbols of humanity's capacity to confront extreme environments. The challenges of lunar colonization, micrometeorites, solar radiation, toxic dust, and isolation force us to invent, collaborate, and rethink what it means to survive. In striving to thrive on the moon, we also gain insight into ourselves, our resilience, our creativity, and the social structures that allow cooperation in the most inhospitable places. And yet, for all our ambition, the moon reminds us of perspective. Standing on its surface, even in imagination, one sees Earth not as a battleground or a stage for ambition, but as a fragile, luminous sphere suspended in blackness. The moon reflects humanity not only in our politics, science, and ethics, but in our consciousness, our ability to contemplate, to imagine, and to recognize the interconnectedness of life. It is a mirror that forces reflection, a silent teacher, revealing what we value and what we risk losing. Even in the quiet lunar night, there are echoes of human drama. The artifacts left behind, flags that have faded, modules that have endured micrometeorite impacts, rovers that stand frozen in time, tell a story of triumph and impermanence. They remind us that while technology and ambition can take us far, human endeavors are fragile. The moon preserves both glory and caution, offering lessons for future explorers who may one day transform distant craters into settlements. The moon also mirrors our dreams for the future. Water ice in shadowed craters becomes a symbol of sustainability, helium-3 a vision of clean energy, and polar habitats a testament to the possibilities of interplanetary life. Yet these dreams are inseparable from responsibility. The same ambition that drives exploration must temper exploitation. How we act on the moon reflects who we are on Earth and what kind of civilization we wish to become. It is a canvas for both imagination and conscience, a place where curiosity must coexist with care. And perhaps most poignantly, the moon is a mirror because it is both constant and changing. Its craters, regolith, and lava plains are billions of years old. Yet every human step, every spacecraft landing, alters its surface in subtle ways. Our impact, though small in scale, is profound in symbolism. We see our history written in dust, our ambitions traced across plains, and our ethical questions etched into every footprint. The moon is not just a rock orbiting Earth. It is a reflective surface, showing us who we are, what we aspire to, and what we might become. As we gaze up at the night sky, The moon appears serene, unmoving, distant. Yet it is alive with stories of humanity, our science, our ambition, our conflicts, our dreams, and our dilemmas. It is a mirror not just of what we have done, but of what we might do. And in the centuries to come, as explorers return, habitats expand, and human presence grows, that reflection will deepen, revealing truths about our species that are only now beginning to emerge. In the end, the moon challenges us to look inward as much as outward. It is more than a destination. It is a storyteller, a witness, a mirror. In its quiet, cratered expanse, we see our greatest achievements, our deepest conflicts, and our most daring aspirations. The moon is no longer merely a celestial neighbor. It is a reflection of humanity itself, silent yet profound, patient yet revealing, constant yet ever-changing. And as we take the next steps into this silent frontier, the question lingers. What will our reflection show future generations? Will they see a species that reached for the stars responsibly, or one that repeated old mistakes on a new world? The moon waits, not as a passive rock, but as a mirror of our choices, our ambitions, and our very nature.